So for the folks that are joining us here in the room, this is our afternoon session with some really exciting presentations from our colleagues in the Wildland and Wildland interface. It is my privilege to introduce our speakers this afternoon. This presentation will provide an overview of common work practices for wildland firefighters and occupational exposures, previous research quantifying smoke exposures through industrial hygiene surveys, and epidemiologic analyses of health impacts of wildland firefighters. We'll be able to discuss current research being conducted by NIOSH to examine exposures and health impacts for wildland firefighters. Our first speaker is Dr. Kathleen Navarro. Kathleen Navarro is a research industrial hygienist at the National Institute for Occupational Safety and Health. Her research focuses on examining wildland firefighters' exposure to smoke, understanding acute health impacts, and evaluating biomarkers of exposure and effect in the wildland-urban interface environment. Please join me in welcoming Dr. Kat Navarro.
Good afternoon, everyone, and morning for everyone else. I'm happy to be here today to talk about the current research that we have going on at NIOSH, looking both at the health of wildland firefighters, but also the wildland-urban interface as well. So last fire season was quite, not only were we having a pandemic going on, but the fire season itself was also one of high activity. So at the height of fire season, we saw over 32,000 personnel deployed out to the Western US to support wildland fire suppression efforts. This work is arduous. You know, we've seen that all throughout the presentations this week so far, and as well as for wildland firefighters really thinking about how are they protected. They don't have any respiratory protection that is currently available for use, as well as a potential for off-duty exposures as well. So firefighters are supported in many thousands sometimes out at fire camps, and these camps are located near the fire line, which can be impacted by smoke both during the day and in the evening when inversions can set up and really trap that smoke in there. So we've heard all throughout the talks the past 2 days, you know, what is in smoke, what is being emitted. These are volatile organic compounds, polycyclic aromatic hydrocarbons, nitric oxide, particulate matter, carbon monoxide, and carbon dioxide. And for wildland fire, this is happening all the way from the flaming, the smoldering, as well as the ash stage of combustion. So out on a wildland fire, you know, firefighters are doing different job tasks, but, you know, some of the ones that past research has shown to be more highly exposed to smoke is lighting, conducting a firing operation. Here in this video, firefighters are doing a back burn, so trying to get rid of all of the available fuel between the fire break and the main fire. So firefighters are using torches with a mixture of diesel and gasoline. Firefighters out on the road are walking and making sure that the fire has not crossed that road, that designated line into the green area to start any new fires. So all of this being done in a highly coordinated effort, but lots of potential for different types of exposure and different levels of exposure as well throughout a work shift. So there's not much known right now for what is the long-term health risks for wildland firefighters, and some of the work that I completed with my colleagues while I was working with the U.S. Forest Service was really trying to get at that and estimate what the lifetime risk of lung cancer and cardiovascular disease was from particulate matter from smoke. And to do this, we used exposure response relationships from epidemiological literature, then paired that with field measurements that we had taken for PM4 out on wildfires, as well as heart rate to then measure breathing rate for wildland firefighters. So for this project, I'll just briefly go over it, but we took the exposure response curves from Pope et al., which aggregated information from ambient air quality studies, secondhand smoke exposure, as well as cigarette smoke exposure, and created these exposure response curves for both lung cancer and cardiovascular disease as an increment of PM dose per day. So we used that breathing rate that we had estimated with our on-the-line exposures from smoke, and then saw that our firefighters were really in this kind of ambient to secondhand smoke exposure categories. And putting that together with kind of these exposure scenarios that we had created, we were able to calculate excess risk of lung cancer and cardiovascular disease. So we looked at this for a short season firefighter as well as a long season firefighter, because we don't really have good information on how long firefighters spend each season out on fires. So that 49 days per year equates to a 500-hour overtime season, and then 98 days per year equates to a 1,000-hour overtime season, which sounds like a lot, but it's what you do when you're only working possibly 6 months out of the year. So we also looked at career duration of varying from 5 to 25 years. So if we take the kind of most conservative estimate, which is that short season, a 5-year career, which I kind of see as like a college student, working their way during the summer in fire, we see an excess risk of 8% for lung cancer and excess risk of cardiovascular disease of 16%. And then kind of going all the way down to that long season firefighter for a 25-year career, that could be your hotshot superintendent, your crew lead, who's been doing it for their entire career. We're seeing an excess risk of lung cancer of 43% and estimated an excess risk of cardiovascular disease of 30%. So what we've been trying to do is really trying to understand, what are firefighters exposed to, how is health affected, and how is health affected over time. Like I said, with my study, it's only an estimate of what our long-term health risk is, but really trying to understand that with data with firefighters out on the ground who are working. So for this, we started the Wildland Firefighter Exposure and Health Effects Study. And this was started by Corey Butler and Kenny Fent at NIOSH in about 2016, I think is when the first wheels started rolling on this. And the study rationale, I've kind of touched on some of this, but there's limited research on the subacute exposures and health effects. Some of the previous work that has been done looks at cross-shift exposures and health outcomes, as well as cross-season, but nothing is really looking at what's going to happen over multiple seasons, what can possibly happen over the career for a lifetime for a wildland firefighter. Limited information on the work environment, the types of risk out there, baseline health information, as well as the wildfire environment, just like the structure environment, includes many, different multiple hazards and exposures happening all at the same time. And every fire is different and every day is different. So for this study, we had a 2-year cohort study with volunteers from 6 federal fire crews working for the U.S. Forest Service and Department of the Interior. And for this project, we assessed changes in lung function, cardiovascular function, kidney function, as well as noise-induced hearing loss. So for this project, we interacted with our study participants 2 to 3 times per year for 2 consecutive years. I'd like to note that this project was designed as a 3-year study, but unfortunately, due to COVID, we had to cut it short. So just an overview of how we did all of our testing periods and just an overview of the study. We recruited our participants in pretty late 2017 is when the crews who were going to volunteer were identified. And we were able to get out for April 2018, where we went to each of these fire stations where these crews were housed and did preseason testing. We met back up with them late September, October for a postseason test. And then in 2019, we did the same preseason and postseason testing, but also went out for 3 days to a wildfire incident that was out in Salmon, Idaho. And we're now in our data analysis and publication of results phase of our project. So just going over kind of briefly, there's a lot of study components and a lot of data that were collected for this project, but our study components included a questionnaire, which looked at risk factors, demographics, as well as medical conditions, our cardiovascular function, we're measuring blood biomarkers, as well as using pulse wave velocity for our arterial stiffness and looking at platelet function. For kidney function, we looked at markers of dehydration, as well as kidney injury, and markers of rhabdomyolysis as well, so that muscle breakdown. For pulmonary function and inflammation, spirometry tests were conducted, as well as fractional exhaled nitric oxide, which is really looking at acute inflammation, as well as looking at inflammatory markers in the blood, and then looking at noise-induced hearing loss, both pre-season, post-season, and during that mid-season event for all of these measures. For our exposure monitoring, we were able to get some industrial hygienists out during that mid-season testing period, and we did personal air sampling for benzene, toluene, ethylbenzene, xylene, aldehydes, and carbon monoxide. We looked at urine to measure for PAH metabolites, as well as level glucosan, which is a wood smoke metabolite, and then looked at job task as well. And so for job task, we actually were fortunate with our partners with the U.S. Forest Service. They gave all of our crews iPads for the season, and each day they marked how many hours they did kind of a common job task out, either doing kind of station work on a prescribed fire, as well as for wildfire assessment too. And I'm excited on kind of what that will give us for if we can kind of create more of a similar exposure group using some past exposure data as well. So our results so far is just kind of an overview of what we've collected. So for preseason and postseason, as well as that midseason in 2018 and 19, we got crews are typically 20 to 25 individuals. And so for our project, we got pretty good percentage of volunteers from each of our projects for a total of 154 participants. It says 155 here, but one crew member moved from the initial attack crew to one of the hotshot crews. So for our study participation, we had a total of 56 participants who participated in all 4 of our study tests, so that preseason and postseason as well, but we still have a good number of folks who participated in at least 2 testing events as well. So for this project overall, we have over 20,000 blood and urine tests, over 500 audiometric tests, around 500 fractional exhaled nitric oxide tests, that acute inflammation marker, as well as over 400 spirometry tests looking at lung function. So this has been a highly collaborative study. We've worked really closely with our partners at the U.S. Forest Service, the Department of the Interior. We received funding from the National Wildfire Coordinating Group. We were working with the union as well. And then we have research partners at Skidmore College. And like I said before, we have over 150 wildland firefighters enrolled in this study. So it was a really comprehensive design, which is leading to some of our study strengths. The limitations for our study include that we have no true baseline samples. I know some of the work that Jeff Burgess and others have talked about, really recruiting incumbent firefighters. We don't really have that because we just had our crews who we were looking to at the time. The timing of postseason and even preseason samples were difficult. These folks are out on the road, they're deploying to fires. So sometimes we were able to get crews that were coming directly off of a fire, but oftentimes they had a few days off once they were done with their fire deployment, and then we would do our testing. We also have somewhat of a limitation is the representativeness of our study population. For the study, we focused on federal crews, particularly those interagency hotshot crews. And of those, they're considered a type 1 resource. So they are a bit more specialized. They have higher fire qualifications. It allows them to be broken off into smaller modules, as well as they are able to take on more complex work assignments as well. So really for any kind of next study, looking at different types of crews will be imperative to really understand the breadth of health outcomes within this population. So some of our research challenges and lessons learned that I just want to share with anyone who's trying to get into this work. Really, our research challenge is recruiting study participants and incident access. So for this project, we worked really closely with our Forest Service and Department of Interior partners to be able to coordinate all of these details and really started initial conversations very early on, like many of the projects described here at this meeting. It's been a very collaborative process between us and the Fire Service. For myself, when I was doing my dissertation research, I went out and became qualified as a wildland firefighter. So being able to be out there on the line has been really great for myself to understand the work environment, as well as how to collect data in a safe way. So this project involved many folks. Over 50 NIOSH researchers have been involved in this project, which really was hard to carry out this complex field research in remote locations and making sure that it was safe. We used a lot of techniques and lab equipment that were not designed to work in a fire camp under a tent like the one that you see here in this photo. As well as, unfortunately, we had an abrupt end to our study due to COVID-19. So we'll be changes in health and looking at how that relates to exposure. We hope to increase the knowledge about wildland firefighter health status and risk factors and really provide the Wildland Fire Service with evidence-based recommendations to reduce exposure to protect health. And I just kind of wanted to give folks a preview of the wildland urban interface, or WUI work that we've been doing. So what happens when firefighters experience structural firefighting exposures without wearing PPE used in a structural response? And for this, we have a project that was funded by CDC and is nested within the Firefighter Cancer Cohort Study. We're looking at biomarkers both of exposure and effect, so looking at both acute and chronic exposures, looking at the PFASs as well as flame retardants, looking at epigenetic changes, so DNA methylation and microRNA expression, and then looking at the urine for post-fire incidents, looking at metals, VOCs, flame retardants. And I'd like to give a shout out to Derek Irwin, who hiked up that hose pack to get those urine kits out to the firefighters. So I first and foremost want to thank everyone who's participated in this work, our research partners at the Forest Service and DOI and Skidmore College, as well as the University of Miami in Arizona, the 50 NIOSH personnel over 5 divisions that worked on the Wildland Firefighter Exposure and Health Effects Project, and acknowledge everyone who's worked on it so far. So I'm happy to take questions, and thank you for this opportunity.
Okay, so I would like to apologize to our audience, both local and virtually, as we are having some technical difficulties and won't be able to conduct the Q&A session. But please do feel free to email Dr. Navarro directly with any questions regarding her study. So we'll move on to our next speaker, who is Dr. Elias Cavaouras. Understanding the patterns of exposure to smoke of wildland firefighters is essential to assess health hazards. This task needs to be accomplished without interfering with safety and duty of firefighters responding with incidents. In this presentation, we'll discuss new wearable technologies to provide almost real-time monitoring of the health and the physical status of firefighters and its application to the field. When coupled with geospatial information, data may be used to recognize hazards, manage resources, and prevent health hazards during an incident. Dr. Cavaouras' research lies on the interface of chemical and health sciences to understand the coupling of atmospheric pollution and human health, including the role of climate change. His research on particulate matter sources and composition development of aerosol characterization technologies, wildland smoke emissions, geospatial receptor and inverse modeling, as well as cardiovascular morbidity and mortality. He has developed novel analytic protocols and geospatial analysis methods and state-of-the-art instrumentation. Please join me in welcoming Dr. Kovaros.
Good afternoon. Thank you for joining us today. As COVID-19 changed our lives, claimed so many preventable deaths, and kept us apart for the last 18 months, we're now coming back together. We'd like to express my sincere appreciation for the organizing committee and all associates who worked relentlessly to put together a high-quality conference and orchestrate a hybrid structure. Thank you. The topic of this short presentation is about new technologies and tools to assess exposures to hazardous chemicals through inhalation and responses at the primary target organ, the lung of firefighters. The content of the first couple of slides is probably common knowledge for you. Bear with me. They meant to set the stage. Cardiovascular disease and cancer are the most prevalent long-term health outcomes among firefighters. It is concluded that occupational exposure as a firefighter is possibly carcinogenic to humans, classified as 2B by the International Agency for Research on Cancer. This assessment is based on the understanding that smoke inhalation during firefighting is the predominant risk factor and that smoke contains an endless combination of hazardous substances that depend on fire characteristics such as the material burned, the intensity of the fire, proximity to smoke plume, personal protective measures, to name a few. It is not surprising, therefore, that the length of employment as a firefighter is positively correlated with increased overall mortality. Wildland fires are now a year-round threat across most of the western United States, with significant events in Midwest and Eastern United States. One of the tools to help mitigate them is through prescribed fires. They're managed burns under certain weather conditions to reduce the amount of vegetation on the ground in order to suppress the spread of wildland fires. We will come back to this shortly because they afford the scientific community a unique natural experiment to understand exposures and health outcomes. Firefighters are charged to deal with these wildland fires. Fires that last for many days, if not weeks and months, over treacherous terrains, sometimes far away from the nearest support center, and only with limited supplies and protection. As such, many of the personal protective devices used in other event types are rendered inefficient. There are no NIOS or National Fire Protection Association respirator standards for wildland firefighting. More often than not, wildland firefighters use basic filtering face pieces like the ones all of us have been using the past 18 months. Of course, these filtering face pieces are not perfect. Many smoke ingredients make it through. Given the trends on the frequency and intensity of wildland fires and the potential to adversely impact more firefighters, it is a priority to understand what is causing these adverse health outcomes and how. With the overall objective, of course, to find new tools and strategies to reduce exposure to these harmful agents. Let me give you an example why it is important to identify the causal factors and their biological mechanism of action. Smoke contains particles of different sizes and chemical content. Using a mask that effectively filters large particles would substantially reduce particle load in terms of mass. However, these large particles do not penetrate to the lungs. They are trapped in the nose and pharynx. Moreover, they tend to be chemically inert. On the other hand, very small particles that account for a tiny fraction of the mass, but they are a lot in terms of number, they make it through the mask, penetrate deep into the alveolar region, and typically contain highly reactive combustion byproducts. The first hurdle is when and where studies to understand exposure and the biological mechanism of action should be done. The studies ought to be in real conditions to accurately consider all synergistics and confounding factors on an individual and population health levels. It is easily understood that it is technically not feasible to do that in an active fire without interfering with the duties of the firefighter and involuntarily compromising safety. We briefly mentioned prescribed fires earlier as a tool to control wildland fires. Although prescribed fires are managed fires with their duration, scale, and intensity closely controlled, firefighters actually are in the close proximity of the fire front and within the smoke plume. Previous studies clearly demonstrated that exposure level to smoke components, both particles and gases, were comparable to those measured for natural wildland fires. Therefore, prescribed fires afford us a chance to understand the causal factors of the adverse health outcomes to firefighters in almost real conditions without compromising health and safety of firefighters and study integrity. In other words, it is a win-win situation. So now, we have the stage to actually perform these studies and understand what and why is causing cancer and other adverse health outcomes to firefighters. The next hurdle is how to better understand exposure to smoke during firefighting. This is a multi-tiered question. It includes when, where, what, and how long questions. And of course, what else was happening at the same time that can modify the amount of smoke inhaled or otherwise the dose. Traditional integrated measurements has been the to-go tool over the past decades for most of the smoke components. They provide an estimate of the average concentration of smoke component in the breathing zone of the firefighter, but nothing more. While this approach remains the only viable method for some pollutants, particularly the size and chemical content of particulate matter, technological advances offer new tools to continuously monitor smoke pollutants. Moreover, wearable sensors can provide information on the location, timing, activity, and physiological responses of the individual. All of them are factors relevant to accurate exposure characterization. We integrated these technologies in our studies. First, a compact, lightweight, continuous particle counter to measure the number of very small and large particles every second. Secondly, a wearable multi-sensor device that monitors physical activity and physiological variables, including skin temperature, heart rate variability, and movement. We also added a backup GPS sensor to obtain secondary location, time, movement, and elevation of the individual in case the wearable technology malfunctioned. The slide here shows an example of the integration of continuous particle number measurements and the location of the individual. The mean gridded fine particle number concentration portrayed highly variable exposure conditions during the fire, with higher levels being measured in topographically favorable locations, such as on the base of the ridge. The firefighters monitored both the perimeter of the fire plot as well as walked within the plot to maintain the fire front. The fine particle number concentration, walking speed, and elevation were mapped for a firefighter, showed that approximately 50 minutes elapsed between the start of the monitoring and the staging area and exposure. In that period, the firefighter joined the briefing by the fire manager and descended about 50 meters to the base of the hill. During the fire, there were intermittent periods of moderate between 1200 and 10,000 particles per liter of air and high more than 10,000 particles per liter of air, indicating highly variable exposure patterns during the fire. High particle number concentration levels were associated with increased walking speed as the firefighters were ascending or descending the hill to manage the wildfire. Low or moderate particle number concentration levels were more commonly associated with firefighters standing along the edge of the fire boundary. We further analyzed this data to better understand physical activity during exposure. It is known that breathing rates vary by activity and going up and down the hills involves some effort. This figure shows the average fine and coarse particle number concentration for 3 walking regimes. Both fine and coarse particle levels increased as walking speed increased from 0.26 to 0.40 meters per second, while the range of measured walking speeds are substantially lower than those recommended by CDC for physical activity. The association between particle number concentration and walking speed provided an indication that the potential of higher exposures when the firefighter was in motion, such as when actively maintaining the fire front through reignition. The increased walking pace could modify the inhaled dose because of increased breathing rate. In addition to better estimate dose, we can also evaluate the immediate effect on clinical relevant variables and the synergistic or confounding factors. It is already known that physical activity increases heart rate. In our studies, walking increased heart rate but remained constant for vigorous activities. At the same time, exposures to fine particles increased, indicating the possibility of a confounding effect of physical activity and smoke. This continual increase in heart rate without change in activity parameters may be due to the activation of the parasympathetic nervous system due to wood smoke exposure. Among healthy individuals, like firefighters, elevations in heart rate during elevated activity translate to increases in alveolar gas exchange and systemic circulation. Increased circulation then increases the risk of particles and other harmful smoke constituents reaching the target organs and further damaging vital structures. We could not miss the opportunity to collect integrated samples and determine the size distribution of polynuclear aromatic hydrocarbons, including benzoalpha-pyrene, a 5-ring PAH, whose metabolites are mutagenic and highly carcinogenic, listed as Group 1 carcinogen by EARC. The plot shows the size distribution of organic and elemental carbon and 2, 3, 4, and 5-ring PAHs. Low molecular weight petrogenic 2 and 3-ring PAHs were abundant in the coarse particles, those that are trapped in the upper respiratory tract. On the contrary, heavier combustion 4 and 5-ring PAHs were mostly present in the fine and ultrafine size ranges, those that penetrate deeper into the alveolar region of the lungs. The differences in the relative abundance of PAHs for different particle size ranges is related to the formation mechanism, with petrogenic PAHs being formed during the low temperature smoldering phase and combustion PAHs during the flaming phase. These PAHs have also been measured on the hoods of firefighters in post-municipal fires as well as in residential dust, and surface contaminated with wildfire ash, suggesting that PAHs from these wildfire events have the potential to affect larger populations in addition to active duty wildland firefighters. The last hurdle is to better understand the biological mechanism of action, since the timing and the duration of prescribed fires is known in advance. It is fairly straightforward that measurements and biological specimens may obtained prior and at the end of each fire, and in a regular period over a season or multiple seasons. Lung is the primary target organ, so understanding its responses to smoke insults is critical. However, obtaining samples of the airways lining fluid is an invasive procedure that definitely cannot be done in a remote location. The next best alternative is to collect the exhaled breath. Contains a mixture of exogenous and endogenous chemical species through gas aqueous partitioning or aerosolization of the airways lining fluid. These biomarkers may identify lung impairment and differentiate pathological conditions, detect genetic modifications, and uniquely identify environmental stimuli. We have developed an untargeted metabolomics methodology using nuclear magnetic resonance spectroscopy to determine differences in exhaled breath condensate spectral patterns following wildland fire smoke inhalation. This figure shows typical proton NMR spectra of pre- and post-exposure EBC, including the boundaries of the 6 non-exchangeable hydrogen types. For both pre- and post-EBC samples, oxygenated hydrogen was the predominant type, followed by alkyl and allylic hydrogen. Trace quantities of acetylic, vinylic, and carbonyl hydrogen were detected. Post-exposure alkyl hydrogen concentrations were nominally higher than pre-exposure, while the opposite was observed for allylic and oxygenated hydrogen. Obviously, this is not a very clear picture. Keep in mind that these numbers were obtained across many fires and multiple firefighters. So, we looked into what is causing this variability, specifically the variability among firefighters. We did that by characterizing the redox content of EBC with the understanding that no two individuals are alike and that the responses may depend on lung physiology prior to exposure. We calculated the non-oxidized in the form of alcohols and oxidized in the form of carboxylic carbon fractions. This figure here shows the post to pre differences on the relative to the total aliphatic concentration abundance of non-oxidized and oxidized carbon for each paired EBC sample. Two regimes were identified, reflecting a strong proportional dependence between non-oxidized and oxidized fractions. The first regime, the oxidation regime, in the upper left quadrant, was characterized by post-exposure increasing oxidized to aliphatic and decreasing non-oxidized to aliphatic ratio values, while the opposite was true for the reduction regime in the lower right quadrant. For the oxidation regime, the mean oxidized carbon increased by 25% and the non-oxidized carbon decreased by 48% post-exposure. On the other hand, the abundance of the oxidized carbon for the second regime declined by 64%, while the abundance of non-oxidized carbon increased by 121%. However, these two chemically distinct conditions may be associated with smoke-induced inflammation, as we described in the paper. This short presentation aimed to highlight recent advances to better understand exposure to wildland fires, smoke of firefighters, and physiological responses and clinical outcomes. These new approaches and tools enable the collection of data and information under real conditions, in which firefighters were actively engaging with the fire front. As a result, these works provide further evidence that prescribed burn events offer a sufficient active fire environment where occupational biomass smoke exposures and the associated health ramifications can be assessed without affecting the safety of the wildland firefighters or the research team. We were able to deploy exposure and health assessment strategies under real conditions over multiple events and years. And for the first time, a fine resolution of exposure and health parameters were simultaneously collected during active fire settings. This work further supports the need to continue the investigation on the health effects of biomass smoke exposure among wildland firefighters through both acute and chronic exposure models. Thank you for your attention.
Thank you so much, Dr. Kavouras, for such a wonderful presentation. So we're going to have a couple of minutes for some question and answers, and then we'll shortly thereafter be turning back to Dr. Navarro to ask her some questions as well. So for our audience that's joining us online or for the folks in the room, please feel free to use the app in order to through Social Live in order to communicate with us the questions that you have. So the first question that we wanted to ask you, Dr. Kavouras, is what are some of the challenges in using some of the remote sensors in wildland firefighters that you've encountered as a scientist?
So, thank you for having me here. It's great to talk to all of you. So the challenges, as Dr. Navarro mentioned before, is starting with recruiting the firefighters and participants to actually do this kind of measurements while they're engaged into their work activities, the work job. So in addition to that is most of these techniques, when we started, it was the first time we were trying to establish them and see how they work. So it's trying to maintain the scientific standards of, collecting adequate measurements over a period of time. Is kind of challenging because safety is priority for the firefighters and things may not work always the way you think. Like with exhale breath condensate, you need to keep them cool at minus 10 degrees in the middle of nowhere pretty much until the event finishes so you can collect the sample, and that can be challenging. But over time, we managed to get these things under control. The technology allows us to do these things now.
Terrific, thank you. We have another question from an online viewer who wants to know that, well, they first mentioned that they know that smoke and soot is not necessarily helpful to be exposed to in the wildland scene. What can wildland firefighters realistically do or expect in order to protect their crews from some of that smoke? If there's any ideas that you recommend that they do.
Well, I mean, there is plenty of work being done on this topic, and Dr. Navarro can talk to that on IOS and the regulations and personal protective equipment on making sure that when you are exposed, until you are using the right devices appropriately to reduce exposure. The second event is, as I mentioned, part of these technologies here include GIS and location, and I think some of the fire departments already use these technologies to identify where their crews are in relation to the fire, and so it might be important to integrate a smoke component there so you can place the troops out of harm's way, of course, and that relates both to fire itself but also the smoke. So integrating that smoke, plume, and information about that into probably the tools that they already have, that can help them tremendously. In addition, monitoring, regular monitoring may be particularly helpful in order to identify maybe firefighters that may be susceptible or overexposed at some period, and then condition them before you bring them back to the field is some of these strategies, which relates to what Dr. Navarro presented before about the subchronic exposures. Our studies look for most acute exposures, but combining both of them is how we can manage exposures and, more important, the health outcomes of these so that they don't accumulate and cause something long-term.
Yeah, that's a great point. We want to assess both like acute and long-term low-dose exposure so that they can retire and enjoy the pension from all their years of hard work and service. Thank you so much, Dr. Kovaros. We really appreciate your time and the presentation today. It was excellent.
Thank you.
We're going to loop back to our presenter, Dr. Kathleen Navarro, just to ask and offer a couple of questions and answers. So Dr. Navarro, one of the questions that came from the room, and I apologize earlier that the audio wasn't working. One of the scientists in the room wanted to know when you would be expecting the results of your study. It's very exciting, and wanted to sort of get a timeline on that.
Right now we're about to submit for publication our methods paper, which will kind of lay the foundation for all of our health assessments that are coming out. But I foresee a lot of our work coming out in early 2022.
Okay, thank you. Could you talk a little bit about sort of the differences in exposure that you would expect to see between WUI and wildland firefighters in terms of the burning structures? I guess they're asking between the exposures that would be encountered in just pure wildland versus wildland urban interface environments.
Well, that's actually what we're really trying to understand with that WUI project. I would recommend everyone also tune in to, there's a recording from this Tuesday. The National Academy of Sciences is doing a committee on the chemistry of urban wildfires. And that's one of the things that folks are really trying to get at is what are those exposure differences. So for this project to get at that, we're looking at metals, we're looking at PFASs, and we're looking at flame retardants, and anything else that can really be a part of a building material and not necessarily the fuel that you find in a forest.
Excellent. And then let's look back to the question that was asked earlier in terms of just practical recommendations for personal protective equipment when out on the scene. Any recommendations that you have for a firefighter?
I think the recommendations that I really tear towards when thinking about the hierarchy of controls is really being at that administrative control level. So changing how people work. How do we reduce exposure daily so that their cumulative exposure over a lifetime, over a career is reduced as well? So I think it's about creating, when the time and place allows, choosing tactics that really get folks out of smoke. I use an example from my own time as a firefighter when I was holding a line and I literally couldn't see in front of me. So I couldn't even do the job that was asked of me, but there were folks to my left and my right who were counting on me to hold that spot. And my science brain knew that it was a terrible idea to stay, but I knew that my crewmates were trusting me to do that. So our squad leader eventually pulled us out and we just did a 2x2 patrol of that area. So for me, it was a real world way of, when the time and place allows, how do we change tactics? How do we change operations to reduce not only exposure to smoke, but exposure to ash as well? And I think the other piece is just communicating that risk to everyone in the fire service. It's really not a piece that we have right now in our firefighter training on the risks of smoke, the possible risks of cancer. And I think it's really hard when you are doing that, when you work in an environment that's full of risks. And how do you communicate about a risk that you can't see?
Right. Those are excellent points. It seems that the future is bright for opportunities to conduct, very rigorous scientific studies to look more into the different exposures, both in the WUI interface as well as in the wildland interface. So I want to thank both of our presenters for their time and for the opportunity for the Q&A. And I apologize again for the changes in the audio. So thank you both. All right, we'll begin with our next presenter, Dr. Darren Warborton. This is a specific talk on the health and wellness challenges associated with wildland firefighting. So wildland fires adversely affect the environment and the lives of millions of people each year. The size, frequency, and severity of wildland fires are expected to increase worldwide with climate change. Wildland firefighting places physiological, cognitive, mental challenges upon the firefighters and the management staff. During fire season, wildland firefighters and coordinators will often work extended periods of time, even greater than 12 hours, with limited time for effective rest or recovery. The purpose of this presentation is to enhance our understanding of the effects of fighting wildland firefighters on health and safety and the coordination staff. This will include an evaluation of the effects of the wildland firefighting schedules and activities on the development of cognitive and musculoskeletal conditions. Particular emphasis will be given to the role of inadequate sleep, injury, cognitive and musculoskeletal fatigue, as well as heart disease and cancer in wildland firefighters. Dr. Darren Warborton is the co-director of the Physical Activity Promotion and Chronic Disease Prevention Unit, and he is a full professor at the University of British Columbia. He is also the founder and director of the Cardiovascular Physiology and Rehabilitation Laboratory and the Indigenous Health and Physical Activity Program at UBC. Please join me in welcoming Dr. Warborton.
Hello everyone, my name is Darren Warborton. I'm a professor at the University of British Columbia in Vancouver, BC, Canada. I really appreciate the opportunity to participate with our esteemed panelists. I look forward to sharing our experiences in the province of British Columbia. In particular, I look forward to sharing the health and wellness challenges and opportunities associated with wildland firefighting. I'd like to start my lecture in a good way by acknowledging the traditional, ancestral, and unceded territory of the Coast Salish peoples and the various Indigenous communities that have welcomed us over the years within the province of BC. We are honored to be able to work, learn, and play on this beautiful land. And at this time, I would also like to honor the memories of the 215 children recently found buried at the location of a former BC residential school in Kamloops, and all others affected by the Indian residential school system across Canada. The purpose of this presentation is to enhance our understanding of the effects of fighting wildfires on the health and wellness of firefighters and coordination staff. This will include an evaluation of the effects of wildland firefighting schedules and activities on the development of cognitive fatigue, altered sleep and physical activity patterns, and an increased risk for injury and chronic medical conditions such as cancer and heart disease. Particular emphasis will be given to our research examining the roles of inadequate sleep and recovery. As discussed eloquently by my colleagues, wildfires adversely affect the environment and the lives of millions of people each year. The size, frequency, and severity of wildland fires are expected to increase worldwide with global climate change. The province of British Columbia is considered a hotbed for wildfires. On average, over the past 10 years, more than 1,300 wildfires have occurred, and more than 347,000 hectares have been burned over the full fire season. The average annual costs are approximately $180 to $200 million for fire suppression. In 2018, which is called a year to forget, there were 2,117 fires that consumed more than 1.3 million hectares of land in BC. A total of 66 evacuations were ordered, affecting more than 2,200 properties. The total cost of wildfire suppression reached $615 million, and a state of emergency was called. BC's forests and wildland cover over 90 million hectares, which is approximately 1 million square kilometers. The BC Wildfire Service employs approximately 1,100 Type 1 firefighters, and the province is divided into 6 regional fire centers, known as the Caribou, Coastal, Kamloops, Northwest, Prince George, and Southeast regions. We are proud to say that we've worked extensively with BC Wildfire Service. The majority of wildfires in British Columbia are responded to by a 3-person initial attack crew. The types of initial attack crew deployed to fight a wildfire will depend on several factors, including the location, the terrain, the size, and the fire's behavior. The BC Wildfire Service has 2 types of specialized initial attack crews, the para-attack crews and the rapid attack crews. There are approximately 390 BC Wildfire Service initial attack firefighters. For larger files, there are 20-person unit crews which perform sustained action. There are 30 unit crews throughout the province of BC. In remote regions, unit crew personnel may live in a temporary fire camp and work for 14 days in a row. As discussed throughout this symposium, wildland firefighting places significant physiologic, cognitive, and mental challenges upon firefighters and management staff alike. During the fire season, wildland firefighters and coordinators will often work extended periods of time, such as greater than 12 hours per day, with limited time for effective rest or recovery. In fact, in BC, firefighters currently work up to a maximum of 14 consecutive duty days before 3 days of rest is required. As discussed eloquently by my colleagues in this symposium, there are several consistent findings in the literature with respect to the effects of wildland firefighting on health status. Common findings include working extended shifts with limited time for sleep and recovery between work periods. There is a reduced opportunity to obtain adequate sleep. And we are also seeing lower aerobic fitness levels. In fact, it's important to highlight that lower aerobic fitness levels are strongly associated with a marked increased risk for premature mortality and chronic diseases such as cancer and heart disease. Wildland firefighters exhibit a disproportionate number of workplace-related injuries compared to typical shift workers, owing to a number of occupational and environmental risks in their daily course of work. For instance, wildland firefighters are highly vulnerable to fatigue and fatigue-related injuries. Common risks seen include extended and irregular shifts, restricted and disrupted sleep, as we've talked about, prolonged smoke inhalation, high ambient temperature, and physical and mental stress. The stress strain is further increased by the use of personal protection equipment in hot and polluted environments, as talked about in this symposium. Sleep deprivation can impair decision-making, hazard recognition, and reaction time, contributing to cognitive fatigue among shift workers. Wildfire management is an extremely stressful occupation that requires large cognitive demands and general mental flexibility in a highly complex working environment. I would now like to change gears a little bit and start to briefly discuss our experiences when working within wildland firefighting settings. In fact, a recent publication of ours in the Journal of Occupational and Environmental Hygiene covers a collaboration with the BC Wildfire Services, where we examined the fatigue and sleep patterns among Canadian wildland firefighters during a 17-day Fireline deployment. A total of 30 firefighters, including 10 female participants, were examined during a 17-day deployment. We examined sleep quantity, sleep quality, and fatigue via wrist-worn accelerometry and visual analog scales. Cognitive function was also assessed using the psychomotor vigilance test. Here's a brief summary of our findings. A total of 416 shifts and more than 5,300 hours were worked during the 17-day study period by the firefighters. The average shift duration was 12.8 hours, and approximately 30% of the shifts were greater than 14 hours in length. The average time between shifts was only 11 hours. We also showed that total sleep time was less on fire days, around 6.6 hours, compared to non-fire days. We also revealed, as shown in this figure, that participants performed poorer on cognitive performance tests. In fact, they had more than double the amount of PVT lapses, reflecting reduced cognitive performance. The participants also reported being significantly sleepier, especially towards the end of their 17-day deployment. Importantly, our participants continued to report high levels of sleepiness, fatigue, and poor quality of sleep on their rest days compared to their fireline days. With respect to the key findings from the study, we can make several conclusions. In fact, we found that working 14 consecutive days was associated with increased levels of objective fatigue and suboptimal sleep within the wildland firefighters. We also showed that wildland firefighters reported significantly higher levels of fatigue and decreased alertness with increasing days of deployment. These impairments do not appear to improve after a 3-day rest period. As such, these findings have significant implications for the health and well-being of wildland firefighters. In a just published study, we assessed 40 wildland firefighters with a mean age of approximately 30 years of age, 13 females, throughout a 17-day with 14 active and 3 rest BC wildland firefighting deployment. Sleep-wake data were obtained using wrist-worn accelerometers and self-report logs. Sleep and shift data were manually entered into a validated biomathematical model called the Circadian Alertness Simulator, CAS, to generate fatigue scores and shift work parameters and patterns. The CAS model calculates fatigue scores using the weighted sum of several output parameters, such as daily sleep duration, variability in predicted alertness, hours of duty, etc. When we looked at the key factors, we saw that the top 3 factors that contributed to firefighter fatigue scores were 1. The total hours worked, 2. Desynchrony of circadian clock, and 3. Sleepiness risk on duty. Shift duration was a major contributor to fatigue in this model, with 46% of shifts being equal to or greater than 14 hours in length, with the average shift length being approximately 13 hours. Contrary to what we had hypothesized, none of the firefighters had a high-risk fatigue score, which is greater than 60 as shown in this figure here. In fact, if you look more closely at the graph, you'll see that the majority were in the lower to moderate risk categories. Based on these findings, we can make some important conclusions. We can conclude that using a biomathematical model of fatigue does provide important insights into work shift parameters that contribute to workplace fatigue and sleep deprivation. We also can conclude that shift duration is a major contributor to fatigue during a 17-day fire line deployment, although none of the firefighters had on-duty fatigue scores that would be considered extremely high risk. In a subsequent study, we examined the association between heart rate variability and indices of fatigue, total sleep time, and reaction time in 10 wildfire management staff. This provided important information with respect to chronic disease risk and looking at predictors, non-invasive predictors of fatigue in wildfire settings. This figure displays the testing time points for each key outcome measure. If you look at this figure closely, you'll see that measures of heart rate variability, sleep time, and subjective indicators were taken on each day, while the cognitive assessments were taken at days 1, 5, 10, and 14 to minimize the burden to the participants. Again, we saw some important findings with this study. We saw mean shift duration, again, was close to that 14 hours, around 13.8. With respect to heart rate variability, we saw significant inverse associations between heart rate variability and sleepiness and fatigue, and a positive association with total sleep time. However, there were no significant relationships between heart rate variability and measures of reaction time, including simple reaction time, choice reaction time, or discriminatory reaction time. We can make some really important conclusions based on our findings. It's important first to state that heart rate variability is commonly used in sporting, occupational, and clinical settings for the tracking of the risk for fatigue, overtraining, and chronic medical conditions such as heart disease. In our study, we have evidence to support the efficacy for monitoring daily cardiac autonomic modulation in response to stressful shift work environments in wildland firefighter management teams. This information can provide really important insight when to make lifestyle modifications to preserve alertness and reduce the risk for fatigue. One of our more recent studies has involved 21 workers aged 21 to 61 years of age. 62% of the participants were female, and we examined sleep using the sleep condition indicator and physical activity using the Godin-Shepherd Leisure Time Exercise Questionnaire so that we could look at patterns in wildfire coordinators. And this was all done via self-report owing to the pandemic during the 2020 fire season. The sleep condition indicator is an 8-item rating scale that was originally developed to screen for insomnia. The sleep condition indicator is valid, reliable, and sensitive to change, which makes it ideally suited for evaluating sleep quality within field settings. The Godin-Shepherd Leisure Time Exercise Questionnaire is a short, valid, and reliable questionnaire that is frequently used to assess leisure time physical activity exercise in a wide range of populations. It involves 3 simple questions about different intensities of exercise, ranging from strenuous exercise to moderate exercise to mild intensity exercise. It's important when we look at this slide and we look at the different figures that there were significant changes in both moderate to vigorous intensity physical activity and sleep quality over the duration of the fire season. In fact, there was a marked reduction in moderate to vigorous intensity physical activity participation and a marked decrease in the sleep quality that the workers experienced. Our study reinforces previous work demonstrating impaired physical activity and sleep patterns in wildland firefighters. But now we have similar evidence in wildfire coordinator staff. These altered lifestyle behaviors are likely due to the stressful and strenuous working conditions. These findings have important implications for the health and well-being of wildland firefighters and coordinator staff. In fact, as shown in this little infographic to the side, we know that improved sleep and physical activity is also associated with improved decision-making and risk reduction in occupational settings. In summary, collectively our findings and that of others indicate that wildfire firefighting is associated with a series of risk factors for injury, impaired cognitive function, and the development of chronic medical conditions and disability. Inadequate sleep and time for recovery appear to play important roles in these elevated risks. A sincere thank you for attending today. Hopefully you found this informative. I'd just like, before we go on, to acknowledge our collaborators, and I'll do that by name here shortly, but also our funding partners, the BC Wildfire Service, WorkSafe BC, the Canadian Institutes of Health Research, and the Natural Sciences and Engineering Research Council of Canada. This work couldn't have been accomplished without the participants, first and foremost, so I'm indebted to all the firefighters and coordination staff that participated, and my colleagues at the University of British Columbia, including Dr. Shannon Braden, Dr. Rosa Miles, Dr. Andrew Jecklin, Dr. Andrew Parada, Giuliano Swartz, Kai Kaufman, Brad Hansen, and numerous other trainees. Finally, I'd like to give a sincere thank you to the organizers of this event from the University of Miami. I've listed their names here. I'm sure there's many more here, but it's been a sincere pleasure to get to know everyone and be part of this innovative symposium. So again, thank you for the invitation. I really enjoyed my time. Thank you.
That was a fantastic presentation, Dr. Warborton. Thank you so much, not only for the context, because sleep and fatigue is such a topic that's discussed within the fire service so much, but also to know that our Canadian brothers and sisters are also being looked after as well. We have a couple of questions that we wanted to ask you this afternoon, so we'll be entertaining questions both from the in-room attendees as well as those that are joining us virtually this afternoon. The first question we wanted to ask you is about the difference between sort of mental and physical fatigue and the interrelationship between the two. How does one sort of unravel when you're feeling mentally fatigued versus physically fatigued, or is it difficult to measure the two in the wildland context?
It's a really interesting question. That's a great question. Something that we've been doing in the lab too as well. And one of the things that we've been studying right now is that cognitive fatigue seems to precede physiologic decrements. So it's an interesting thing is that we're seeing physiological fatigue contributing to cognitive fatigue, but decision-making is affected really early. And this has really important implications. I know in California, very similar terrain to BC wildfire areas, and we're talking about doing wildfires in areas where there are cliffs, like 300-foot cliffs, and limited viewing, and then you have to make life and death decisions about your own safety and your partner's safety. And we're seeing that without adequate sleep, that cognition early on is impaired. And this is what we're seeing really early. If we tracked over those 17 days, that we were seeing early on cognition impairments before what we were doing, but it is hard to partial it out because of the field setting. What we're doing in at UBC is we're actually doing baseline research testing that's actually allowing us to fatigue people, analogous to what you would do in the field setting without the influence of smoke inhalation, for example. And we're seeing, again, pretty consistent data. The cognition starts to be affected really early on, and then later on we start to see the physiologic decrements that are classically associated with wildland firefighting. But that's a great question. It's hard to partial out for certain.
And the way that it's measured, could you comment a little bit? For example, looking at mental and physical, sort of on a survey instrument.
Yeah, so it's an interesting one. So we do both, and we do visual analog scales, which are really good for sleepiness and giving us some quantitative and qualitative insight. So we can quantify on a 10 centimeter VAS scale a lot of the sleepiness measures, but we also objectively measure sleep through accelerometry. So that's a challenge. I was actually sending a text to Elias during his asking how expensive his devices are, because every time we lose a device, as he said, we cry because they are exceptionally expensive. But the one thing that we're seeing with cognition is that we can do field-based tests. So we've been doing a variety of different cognitive tests that we try to minimize the time, and it's direct looking at reaction time. So we're getting some really good indications, whether it's choice reaction time or just simple reaction time or discriminatory reaction time. We're getting some really good indications that there's delays in processing, executive memory. We're seeing the inability to remember things, so the inability to make quick decisions. And that's something that we're seeing relatively early in active deployment. And I think that's really important, because when we talked about the CES, that gave back saying shift length. It's really intuitive. People that work in wildland firefighting said, of course, that's an obvious finding, that shift duration is really important. But what it says is objectively, we need to look at the ratio of sleep and recovery and the time given, right? So if they're working consistently more than 14 hours a day, which our people were doing, there's very limited time for rest and recovery, and we're seeing that directly in cognition. So then you put that again back into the field setting. That has enormous implications. And the really interesting thing from this, Alberto, is that it's not just seen in the firefighters, it's seen in the wildfire management staff that aren't exposed necessarily to the same amount of smoke exposure or heat. Right, they are exposed to a certain extent because of the camps and the various areas that they're located, right? But they're not exposed to the exposures that we talked about nicely in the previous talks. So this is an interesting thing, saying that they're at risk too as well. And we believe that a large part of that is related to their sleep work patterns that they have and recovery patterns. It's a great question, though.
Yeah, it's an excellent point about, we had a lecture yesterday on total worker health and its overlap. So it shows how like not only the direct wildland firefighters, but also the coordinating staff is impacted. Would you be able to comment on how, like a practical intervention, what you could be done to mitigate fatigue when you're working, for example, a 2-week roster or a 3-week roster?
Yeah, it's an interesting discussion. Again, a lot of the work now is looking at trying to get that balance between shift length, shift start time and end times is really important. Time between shifts, these are all key things that we're looking at. And in fact, the CAS model that we use, which is quite frequently used in like air flight and long haul drivers, we were surprised because we didn't see an elevated fatigue risk. But in that situation, the shift start times weren't as early as other years. So in the workplace, minimizing the fatigue in the workplace, looking at those, especially those operational shift parameters that can be changed by the management staff, that's really came out, I think, really strongly in our evidence, saying that you can actually work together with the data. And that's just something too as well. We've been working a lot with trying to get some novel, simple measures that workplace firefighting management staff can actually do within the workplace. So the heart rate variability has been one thing too as well. So that's a simple measure that takes 5 minutes in the morning. You can actually teach the wildfire firefighters to actually do that themselves, and they can actually get a good baseline that reports back to the coordination staff and crew leaders about how much recovery they may require. And we do that with our Olympic athletes. So one of the teams that I work, one of the portfolios that I oversee is a Canadian Olympic team and Olympic athletes. And we do that with our Olympic athletes. So it's analogous to this overreaching and overtraining syndrome that you see in elite Olympic athletes, because wildland firefighters are athletes. They're exceptionally trained. And what you see is this decline in fitness and physical activity over time, concurrent with their sleep patterns and recovery time. Right. And with that comes poor decision making. And so the firefighters, when we show
I think we're all back now.
there, perfect. Yeah, thank you. That's a great question. Thank you so much.
Okay,
Perfect.
so Dr. Warborton,
Yeah, thank you
sorry,
so
we had
much,
some technical difficulties.
Alberto, that's a really great question and insightful.
Darren, if you can hear me, I want to apologize because I believe we had some technical difficulties, but the stream is now back together. So you left us off immediately after the Olympic athletes that you were working with before. If you could continue just a little explaining about that component.
Technical difficulties. We made it all through almost 2 days, you know. So we were bound to get a little bit. So we'll make sure any questions we didn't capture from that session we'll try to address at the end of the day. So our next speaker, Dr. Gibson, is an associate professor and researcher in exercise science at the University of New Mexico, with research interests in body composition and physiological responses to exercise. She developed the ancillary materials for the 6th edition of Advanced Fitness Assessment and Exercise Prescription, in addition to co-authoring the 7th edition. Dr. Gibson's presentation today will focus on a study that examines physical fitness amongst career firefighters and a comparison of the results to normative data and suggested standards for their profession. Dr. Gibson, welcome.
I'll see if I can master this slide advancer unless I have some assistance from the back of the room. Yes? Thank you very much to the committee for the invitation to present. This is the Hauk paper that Dr. Warborton referenced in his slides. And I was pleased to be part of that. So again, I am appreciative of the opportunity to present our work. So I'm not sure which of these buttons advances the slide. Green one in the middle. Whoop, that's a laser pointer. That green one in the middle. Okay. I was beginning to wonder, because this presentation seems like a little bit of a lack of fit, but given Dr. Warburton's introduction to this fits, I think, rather nicely. I don't have to tell you that firefighting is a high-risk occupation. You've heard numerous presentations during this seminar or symposium that have highlighted that, and physically, psychologically, environmentally, the PPE itself presents additional risks, and the demand on the heart just based on the weight of the PPE itself, in addition to the inability to dissipate body heat. It's not surprising that given all the risk factors associated with this occupation and the obesogenic environment in a fire station, which I understand there was a presentation last night about diet and nutrition in the fire station, that most of the on-duty deaths of firefighters are primarily cardiovascular in origin, although it's sounding like cancer is more of the long-term result. The leading cause of these deaths is a sudden cardiac event. So it's also known that the increase of potentially severe but non-fatal cardiac events is also increasing annually in firefighters. My area of expertise is exercise science, and we know that there is a direct correlation between one's lifespan and one's aerobic fitness level. The NFPA has recommended that there is a minimum standard that should be maintained. It's not mandated, but that value is 42 mLs of oxygen per kilogram of body mass per minute. If the firefighter has an aerobic fitness capacity lower than that, then they typically have a reduced performance capability in the simulated fire suppression challenge. It's also very important that they maintain muscular fitness through strength and power. Extremely important for all the activities that are performed, but the standards against which to compare the results of these things are unknown at this point, and there is no universally accepted test battery. There are a lot of options, but nothing has been cemented yet. This is a retrospective analysis of data we helped collect from an annual firefighter health assessment in a community in northern New Mexico. We helped collect the data. We had to get IRB permission to actually access de-identified data for our results. When we could find firefighter-specific norms or recommended levels, we use those. Otherwise, we use results from the general population. We assessed urban and wildland firefighters. I must say we had far more urban firefighters than we did wildland firefighters. The health assessment annually was not optional, but the participation in the physiological assessments was. The commanding officers, the fire chief and the captain, identified which assessments would be conducted. And this was based on continuity. This is what they had done the prior year to our involvement. And they were hoping that this would become a longitudinal assessment. You can see by the 2 different days, there are obviously different assessments performed. And the people from UNM, the university, conducted those with asterisks. And the PFTs in the station conducted those that are marked with the other symbol, but they use protocols that are standardized and instructions we gave them. With research studies, obviously you want to have pre-test guidelines. It's the best way to get consistent results, pre-test to post-test or 1 year compared to subsequent years. And the ones you see listed on the screen are primarily due to the body composition assessment method we used, as well as for the maximal aerobic capacity test that we used. During the health assessment, the physician associated with the fire department had the firefighters answer a personal health history questionnaire, and that information was used to determine whether or not there was a pre-existing condition that precluded their participation in the physiological assessments. You can see the statistical analyses methods we used. Since there are no differences in the standards for wildland firefighters compared to urban firefighters, all data were pooled. We analyzed the VO2 max data or maximal aerobic capacity data by sorting them and then identifying quartiles. The quartiles were used for mean comparisons across groups, and we also did correlations with aerobic capacity and cardiovascular risk factors such as body fat percentage, body mass index, and blood pressure. We also used frequency analysis. As I mentioned, these were assessments designated by the fire captain and the chief, and they were made by appointment all during people's shifts. There were 2 informed consents that had to be signed, one for the fire department and one so that we could access their data. After they voided and changed into exercise attire, they had a seated resting blood pressure assessment. They removed their shoes. We were able to get their standing height. We got their body composition by having them then remove their socks and stand upon a multi-frequency bioimpedance analyzer, as you see there on the screen. And the max test we performed was on an electronically braked bike, which means that the computer controlled the workload changes. That computer was the same one that was monitoring the metabolic gases that were expired. The protocol was a 20 watt per minute ramp protocol, and the firefighters participated in the test until they reached the point of volitional exhaustion, or they could not maintain 50 RPMs per minute in their pedaling cadence, or we saw something on the EKG or in the blood pressure responses that would cause us to terminate a test. The day 2 assessments were for upper body endurance. That's the YMCA bench press. We use grip strength because that's an important task-specific assessment. We used a sit and reach test for hamstring and low back flexibility, and we used the Margarita Kalaman sprint up the staircase for lower body power. For the bench press, you can see there are differences in the weight lifted for men and women, but they all had the same lifting pattern: push up on one beat, return to the chest on the next beat. Total number of repetitions performed before they broke form or could not keep up with the cadence. Those were counted. For the grip strength, they squeezed the handle for 5 seconds. then switched hands, squeezed again as hard as they could for 5 seconds, then took 1 minute of rest. This was repeated 3 times. We took the highest value with each hand or for each hand and summed those, and that sum was used in the data analysis. The sit and reach test requires that they sit on the floor, knees extended, feet out in front, fingers overlapping, and they push a little slider bar as far as possible while maintaining contact, but it's done in a smooth motion and they have to hold that for 2 seconds. And we took the best of 3 trials in that one. And if you've never done a Margarita Calaman challenge, you get to sprint up a staircase and skip steps. So we used electronic timing gates. They had a 6-meter approach where they gather speed. They had to hit with 1 foot on the 3rd, the 6th, and the 9th steps. And the 3rd step and the 9th step are the ones that triggered the timing gate to go on and off. We recorded the fastest of the 3 trials. And that last calculation there is converting their body mass, the vertical distance that they covered, a constant, and then divided by the time to complete the challenge. And that gave us power output in watts. These are the data regarding physiological and performance results. I want to call your attention to the body mass index right here. If you know body composition, you recognize right away that's overweight, for example. The next line down, however, is the body fat percentage from the bioimpedance analysis, and that is a lean male and a very lean woman. And systolic blood pressure, according to the norms now, or the criteria now used, is elevated, but the diastolic blood pressure is in normative ranges. And the rest of them are the means for the day 2 assessments. From the MAX test, you can see that our firefighters, on average, did not hit that 42 mLs per kg per minute criterion. We were below it on average. We also saw that the systolic blood pressure increased with increasing exercise intensity, and that's expected. But what was not expected is their diastolic blood pressure also increased. Diastolic pressure tends to stay right around the same level it was at rest. But there were no significant differences based on quartiles. And speaking of quartiles, that's what popped up when I thought I was, doing that, going backwards. Quartile 1 is the most fit group. You can see for each quartile, there is a lower and upper bounds as well as an average. Skipping down to quartile 4, that is the least aerobically fit group. And quartile 2 is a typo on my part. The average should be 40.2 plus or minus 1.4 mLs per kg per minute. But you can see as we increase in quartile number, we also decrease in aerobic fitness level. For the MAX test, we used a cycle ergometer. So it's best to compare results to cycle ergometer data. And we have a large database that we were able to access. And what we see is 53% of our sample finished in the top 20% in accordance with that data set. And about 83% finished within the top 50%. Even though on average we were below the NFPA recommended minimum. Now looking at body composition, we have body fat percentage on the vertical axis, and you can see the quartiles of aerobic capacity on the x-axis, with quartile 1 again being the most aerobically fit and quartile 4 being the least aerobically fit. The only significant differences were between quartiles 3 and 4 in relation to quartile 1, which means that the more aerobically fit you are, the leaner you are, or that's the way the data typically ran on average. And quartile 4 was also significantly different from quartile 2. Now looking at body mass index, which unfortunately is more commonly used as a proxy for body composition, but it does not tell us anything about how the body weight is distributed, whether it's good weight, muscle and bone, or is it bad weight, which is fat mass. And you can still see a similar pattern in that we have an increasing level of body mass index on average in relation to a decreasing aerobic capacity. And again, quartile 4 is significantly different from both quartile 1 and quartile 2. Now looking at body fat, the percentage itself, and we turned this into frequencies, and then the frequencies became a percentage, and the category labels are from the American College of Sports Medicine's guidelines. And you can see that for body composition, hang on here, got to find the right button. Most of our sample, from fair to very lean. But if you look at the body mass index, what you see is the great majority is considered overweight. And as I said, body mass index cannot tell us anything about body fat. And it is body fat percentage that is the health hazard. The results from those day 2 assessments are shown here on the screen, along with their mean and standard deviation. Using the normative value category labels, you can see that we had a nice response in terms of upper body endurance and grip strength, our flexibility of the hamstrings and low back, a little bit above average and all the way up to well above average. And we had a moderately good response to the STAIR challenge, the Margarita Kalaman lower body power assessment. So to summarize our results, only 22 of the 80 firefighters that participated in this study met that standard, recommended standard of 42 mLs per kg per minute, and 20 did not meet the minimum at all. And non-strenuous firefighting tasks are believed to be 33.5 mLs per kg per minute, which is a little bit more than almost 10 times the result of rest. Although we did not have the data to analyze this, it was reported that the higher one's aerobic capacity, the less air they are required through their SCBA. Some differences in why we may have seen lower than expected results in our aerobic capacity is we used a cycle ergometer instead of a treadmill, and we also were conducting these data analyses or data captures at an elevation of over 6,400 feet in the foothills of the Rockies. Had we been at sea level and using a treadmill, we probably would have seen increases in the VO2 max of approximately 10 to 15%. There is an inconsistent methodology in firefighter literature regarding how max tests are conducted, or were they just estimated? Was metabolic gas collected, or did they just go on a calculation? So that's very inconsistent, which makes data hard to relate across studies. And you can see results from Tim Lohman's work, big body composition researcher in Arizona. And you can see that the 18.7% on average for our sample was in range for the men and below range for the women. Also, SME and colleagues have indicated that when body mass index is in the overweight or obese category, or body fat percentage is out of range, then that firefighter is at an increased risk for injury. And it's not just that firefighter that's at risk, it is the people on shift with that firefighter, if they have to get that person out of trouble. I urge you to use caution when using the body mass index as an indicator of body composition, because it is insensitive, and firefighters tend to have greater skeletal muscle mass than do the general population. And body mass index will just say, oh, that extra weight is fat. And that's not necessarily true. We use bioelectrical impedance, which is completely dependent on a euhydrated state. If the firefighter is dehydrated, the analyzer will determine that they are fatter than they probably are, because it's the water and the electrolytes in the water, or the fluids, that conduct the electrical current. But we did very well on our field tests, or the task-specific assessments of day 2. And I like this schematic by Smith. It shows not only the physiological stressors associated with firefighting. You notice that on the top, they are all interrelated, but it also shows down here the benefits of physical fitness. And we can see if we have an increased cardiovascular capacity or a high VO2 max, then we are less likely to be throwing clots. That could be due to the fact there's increased plasma volume. Increased plasma volume is related to improved thermal regulation of the body and tolerance for higher temperatures, as well as recovery. And Dr. Warborton just spoke about the importance of recovery, and it is key to remember all recovery is aerobic in nature. So if we have strong aerobic capacity as well as muscular strength and power, then that should be a healthy firefighter. Some key references: this is the study that Dr. Warborton referenced. And I'd like to thank you for your attention, both in the room and those from out and about in the remote world. And oops, hang on, I'll master this yet. At the end of the slide. It didn't show up. Okay, I had added thank you to all the firefighters, all of them, and the research team that helped collect data, but that didn't make it. And my email ID is on the slide there in case it will be of reference to anybody. Okay, thank you.
We'll do some Q&A together. Is your mic okay? Okay, awesome. All right, so we have a few minutes to do a Q&A with Dr. Gibson, and I'm thankful very much to her for coming to the conference all the way here in Florida. So this is an opportunity to ask her questions both from our colleagues online. So if you wouldn't mind typing your questions into the chat, or anybody here in the room that would like to ask her a question, please feel free to come up to the mics and ask as well. One of the questions that I have is, what are some practical, exercises or interventions that could be done to improve fitness, given its relationship to some of the factors that you alluded to earlier? So if I'm a firefighter in the wildland context, what are some that could be done to improve fitness?
Okay, thanks for the question. There are a variety. Obviously, we need to, well, at least where we collected this data, they had a fitness facility. They had a weight room and had some cardio equipment in it, but I never saw people using it because it's in the fire station, and they would be likely to use that if they're on shift and in the firehouse, but you don't want them worn out. So what people can do, obviously, any kind of cardio activity, high intensity interval training may be of more interest to, especially to the young men, because it's a hard workout, very short period of time. It can be done in a cardio setting where it's, good for the heart, because whatever's good for the heart is good for the head, and that may help with cognition. Yep. And also you can do body weight circuits, or you can set up a circuit with like hand weights, barbells, those types of things, and get a really good comprehensive workout in a very short period of time.
Yeah, that's true that they have their gym inside the station, so you can leverage some of that there. Earlier you mentioned about some of the, pitfalls or challenges with using height and weight and estimating BMI. Is there any instrumentation, say like if bioimpedance doesn't work well because of hydration, is there another instrumentation that's preferred for measuring of body fat calculations?
If you're speaking of measuring body fat in a fire station, I would say skin folds are the next best.
Oh, calibers, okay.
But they've been well researched. I mean, this goes back into the 50s. But you need to have a very skilled technician in order to do that, and there are not conversion equations for all ethnicities. Example, there's no Hispanic male equation. So there's some of that is problematic, but I would do that. Waist to height ratio is also very acceptable, and that's easy to do as long as you pick a recommended weight circumference area. So like midpoint between the lowest rib and the top of the iliac crest in relation to height, that should not be more than 0.5.
Okay. All right, excellent. Thank you. For a firefighter that is going through cancer now, what recommendations do you have, for fitness or exercise for them? So we've been talking so far about before, but if you do get diagnosed with cancer, any recommendations that you have?
Well, I think a lot of that is going to, just a little bit outside my range, but I would definitely check with the physician, with your supervising physician. But anything to increase stamina, I know with breast cancer, and that wasn't typically one of the cancers that was listed in this symposium, but it helps with toleration of the treatment, especially chemo, and it also helps with feeling more in control of your life. So I would suggest any kind of cardio, even on days when you just feel like horrid. Get up and walk, at least if nothing else, walk. And other things that you enjoy doing. If you enjoy swimming, do swimming, but if you have surgical wounds, then you need to wait till those are healed. Some strength training with a lightweight could be done. And again, it all depends on the type of cancer that you have and what your physician recommendations are.
Right, excellent. Okay, I think those are all the questions we had online. Are any questions from our audience here in the room? All right, well, thank you so much for your time this afternoon. A really terrific talk, just to highlight the importance of exercise in our wildland firefighters.
They happened, the wildland firefighters did happen to have higher aerobic capacities and lower body fat compared to the urban, but we had so few of them, we couldn't make a statistical comparison, but just anecdotal. Yeah,
but that sounds like great opportunities for research for budding scientists that are watching us remotely today. Thank you so much. Okay, so our next presentation is with Kelly Kane and Molly West. So I'll begin by introducing our Kelly Kane. Being enamored with the natural world her entire life, beginning with growing up on a remote pig farm in Montana, Kelly joined the Wildland Fire Service in 1988. Intrigued and curious about all aspects of wildland fire and aviation, she worked with 3 agencies, the USFS, the BLM, and the NPS, on helitack, engine, hotshot crews as an FMO, fire planner, regional assistant director for both operations and cooperative fire. She flew helicopters privately in between. She currently serves as the Fire and Aviation Risk Management Specialist for the United States Fire Service, Washington office, with a focus on supporting the physical readiness and the mental fitness of our responders. Molly West is a biological scientist with the United States Forest Service National Technology and Development Program in Missoula, Montana. She first joined the Forest Service in 2010 and has since worked in a variety of positions. Her work with the Forest Service focuses on various aspects of wildland firefighter health and safety. Please join me in welcoming both of them to the stage.
Thank you very much. Can you hear me?
Loud and clear. Thank you, Kelly.
Perfect. And is my PowerPoint showing there?
We do. We see it here on screen.
Oh, perfect. And is my PowerPoint showing there?
We do. We see it here on screen.
Fantastic. Well, thank you, everybody. It's truly an honor to be talking with you today, and I'm humbled to be engaging with both you and with my cherished colleague, Molly West. She will talk here after I give a little bit of an introduction. And I truly am just here speaking today to you as a 34-year career wildland firefighter. I'm not trained as a medical practitioner or a researcher, but I have had just a really profound career. I love wildland fire, and I have a great respect for our firefighters. And so it is with great humility that I thank those of you who are making our world better. This work has many rewards, and I think a lot of you are aware of those. You know, we have the opportunity to serve, we have work with purpose, adventure, and the opportunity to work with really committed individuals and build really strong relationships. That said, we're here today to talk about some of the rigors. So let me see if I can actually get my PowerPoint. Oh, well, we're going to cover a few things today. I just want to go over what some of our cultural norms are, what some of the fallacies about that are, and exposure points. And then Molly's going to talk to some of the science and future efforts that are occurring. So if we start with the culture of wildland fire, things have changed over the course of my career. And I would say even over the last 5 and 10 years, we have noticed increased complexities in the work that we do. We have gone from fire seasons where we used to have a few months out of the year to sort of decompress and plan and whatnot to a year-round fire season. We're seeing expanding growth within the wildland urban interface, which presents increased values at risk across the landscape and in our wildlands. We're seeing changing climates with, we call it weather weirdnesses. I mean, I'm here in Anchorage, Alaska presenting today, and last weekend here in South Central Alaska, we had lightning, which is somewhat of an anomaly, especially for this time of year. We're experiencing increased vegetation buildup in our fuel loading, and some of this certainly is because of our fire suppression due to values at risk, but also there's many other factors that are involved there, which puts increased pressure on all of our folks to be aware of that. And then we're more engaged in all hazard responses. So our personnel are trained in the incident command system, and we're being asked to respond to floods, hurricanes, 9/11. So there's just increased complexity in the work that we do. So let's start here. The nature of our work is dirty. We're not necessarily dirty people. Rather, there's oftentimes limited access to showers and water sources to provide for, our hygiene. There's oftentimes a trade-off, really. Am I going to stand in line if there is a shower available, or am I going to go try and get that much needed rest that Dr. Warborton talked about? And then there's also, and I can speak from my personal experience here, sometimes there's a resignation to the dirty nature. You start becoming dirty and you're just like, well, here it is. I might as well just embrace it and continue on, just sort of that human side of it. So There's also, we have some cultural superstitions. We used to say, oh, nobody on our crew could shower because if we showered, that meant we would be demobed and sent home. And so these are some of the funny dynamics that go on within our culture. But let's discuss some real world opportunities for these routes and exposures to toxins and carcinogens through inhalation, absorption, and ingestion. So inhalation, certainly from burning vegetation, from fires. One of the really important things that I would like to truly emphasize is smoke from ignition devices, whether it's fusees that we use to light vegetation, or our drip torches, which contain oil, gas, a diesel mixture. The smoke that comes from those devices in close proximity to our airways, it's a black smoke. And anytime you talk about it, and for those of you who are wildland professionals, when I talk about this, it resonates. There might be a visceral reaction. Long duration exposure to smoke in camps where we sleep and we eat, which has been mentioned already a couple of times. And then dusty roads, and then digging in dirt, so there is a constant influx of toxins towards our airways. Through absorption, just our contaminated fire clothing, which we can tend to wear for days on end, especially if we're in remote camps away from an organized fire camp, which contain oils, gas, exhaust, and smoke. We carry these containers on our backs. We spill. We utilize chainsaws where there's often gas and oil that ends up on our clothes. And then we talk about sooty legs. So again, those of you might relate to this. I know when you've been out on the line, whether it's sometimes a day or days on end, and you pull up your pant leg and your skin is blackened from the dirt and the soot, as well as face and neck, and just understanding the importance of trying to remove some of that in a way daily. And we can go days. Oftentimes, again, access is limited. Another item is our gear stored in vehicles. And I know this has been a point that Structural Fire has engaged in, and we are trying to learn more about this as well. Our packs, and whether it's our fire packs, our day packs, or the packs that we put our gear in for multiple day assignments, are oftentimes located inside those vehicles, whether it's our engines or buggies. And so it's in constant proclamation to us and providing that exposure, because those items too get soiled from the oil, gas, etc. So that, I think, is a lesson that we might be able to learn. Ingestion. So in mopping up, when we're trying to eliminate hot spots, it's not a dirty little secret that majority of our work on the line can be consumed through mop up, and you're oftentimes digging in the ash for days on end, and the opportunity for ingestion of those materials, as well as a lack of hygiene when we're eating out on the line. We certainly don't always take the opportunity to provide for that. And I know oftentimes just even dropping your food, if you've only got a few seconds to try to get something to eat, and you just pick it up and throw it back in your mouth. And so the propensity for exposure there. So it's easy, I think, for us to go directly to smoke, and that is a topic that we are obviously very concerned about and interested in when we think about cancer within the wildland fire community, including the ingestion, absorption, and inhalation. But I would offer other considerations, and I'm really grateful to the previous speakers who talked about fatigue and fitness. Our firefighters and we as management are very concerned about health outcomes associated with long-term fatigue. This is the day after day, season after season, and now year after year, and what that is actually doing to both our respiratory and cardiovascular health. as well as that cumulative and chronic stress. And the stress, as mentioned, it's not just our firefighters, it's clearly our management, and it comes from managing not only the circumstances at hand with our responses, but the overall management with a limited capacity of our personnel and these increased complexities. And then, trying to have some sort of work-life engagement. We no longer are saying balance because it can be very out of balance. And as Dr. Navarro pointed out, the 1,000 hours of overtime used to be somewhat of an anomaly as soon as 10 years ago. Now it's becoming more of a constant, and now we're seeing even 1,500 hours of overtime in our personnel, both our line firefighters and our management. And so what truly are the effects of that, in addition to the roller coaster of stress that occurs, high stress and then you come down, high stress, come down. So these are things that certainly we are very interested in, and we're grateful that it is on the purview of many of you who are doing research and work in medical fields, because we also are considerate of what does long-term dehydration look like as far as making us more predisposed for some of these health impacts, including cancer. So considerations, and maybe this is the question of all questions, but what really compels us and motivates us as humans to make changes in our behaviors when we receive this valuable information? What research and applied practices can we benefit regarding not only what has already been learned in structural fire from our brothers and sisters there, but some of the work that you all have presented today, and then motivating us into the future to take a closer look at what this could look like. I believe that together we can provide a better future for our firefighters, and I think it's imperative. I also believe that small changes in our culture can truly lend to significant health benefits. And again, I just want to thank you for those of you who are providing the information, the lessons we can learn, and the significant and crucial research that goes into us making changes to change our culture. And with that, I will stop sharing my screen and turn it over to my colleague, Molly West.
Welcome, Dr. West. We can hear you and we can see you.
Okay, great. Let me just get the presentation up here. Can everyone see that?
Yes, we can now see it at the outline.
You can see the outline or okay, but the slide's all good enough?
The slide does appear with the title outline in orange, so we can see that slide.
Okay, perfect. Great. Well, I want to say thank you so much to Kelly, and hello to everyone today that's both joining us virtually and in person. My name's Molly, and like Alberto said, I work for the Forest Service in a variety of areas of wildland firefighter health and safety. And so now that Kelly has really elucidated the wildfire setting and culture and the ways in which wildland firefighters can be exposed, and how we can think about this larger picture of wildland firefighter health when we're making changes, I'm going to briefly visit a couple examples of existing wildland firefighter research to discuss ways that we can continue to and also learn from and apply what's already known. But also I'm going to highlight some of the challenges and the gaps in the wildland fire environment as well. And so kind of in a really high level summary, 4 recent review papers that really specifically address wildland firefighter exposures and health effects really discussed how the health effects or how overwhelmingly this literature focuses on 2 areas. One of them being acute exposures, most commonly looking at particulate matter, and the other being acute physiological responses, most commonly looking at different measures of lung function. And so compared to structure fire counterparts, chronic and cumulative exposures, as well as understanding cancer risk and incidence, remain largely unknown. There were 3 recent studies that begin to scratch the surface. Kat talked to you about her risk assessment looking at lung cancer and cardiovascular disease, but I'm really going to talk on a couple examples of studies in the acute exposure and response fields. And so this was talked about earlier today with the IARC presentations, but one possible way we can organize and look at the studies on physiological responses to known and potential carcinogens is through these 10 key characteristics of carcinogens listed here to the left. And so an expert committee led by Martin Smith at UC Berkeley recently published a paper, and they also, from years and years of work with different IARC committees, where they discussed the applicability of these key characteristics of carcinogens as a good approach to evaluate a broad range of potential cancer hazards. And so these key characteristics can provide us with a really good framework to look at some of the mechanistic evidence in cancer hazard identification. And so the 3 characteristics highlighted here, not the only ones, but 3 that are looked at in some of the wildland firefighter research. And I'll talk about a few examples of those many studies on the next slide. And so this a little bit of a busy table, but looking in the second column, you can see that 4 of these 5 studies, they conducted repeated measures pre and post shift when wildland firefighters were exposed to smoke from prescribed burns, and then some studies also on non-burn days, where that one study in the middle in Portugal, they measured participants who were in varying stages of their career. At one time point, they measured them and then compared them to population controls. And then in the third column, you can see the different key characteristics that the biomarkers and measures from each of these studies, what they highlighted and which key characteristics they might fit in. And then the right column highlights that there's a really big variability in results when we're looking at all these different settings. And then this highlighted cell here is an example of where they found an increase in inflammatory mediators in lighters versus holders. And going back to some of the things that Dr. Navarro as well as Kelly talked about, these results suggested that diesel from the drip torch fuel might be contributing these increases in these inflammatory markers. And so coming back to trying to, like Kelly was saying, trying to categorize and understand the concurrent impact of all of these varieties of inhalation exposures that Kelly touched on is, looking in the research and finding some of these kind of targeted areas of the job and these job tasks, whether that be on prescribed fire or wildfire, that we can kind of begin to understand and figure out what are some practices that we can do to reduce exposure in these areas where the exposure is not just coming from the wildfire smoke, but other parts of the job as well. And so next, talking about the other area of research that was really kind of highlighted in those 4 reviews is acute exposures. And so I wanted to highlight some of the work that Forest Service researchers have done and carried out in smoke exposure. And so the Forest Service carried out an initial comprehensive smoke exposure study that consisted of multiple projects starting in the late 80s, early 90s. And then there were 2 similar follow-up studies years later, one from 2009 to 2012 and 2015 to 2017, led by George Broyles and then Joe Dimitrovich with the Forest Service. And so one goal that's actually really common kind of across all 3 of these studies was really to evaluate wildland fire personnel exposure to smoke and then translate those findings into some potential smoke management strategies that firefighters at all levels could use. And then the subsequent studies were also able to evaluate if exposures were changing over time. And so for all of these studies, the partnership between wildland firefighters themselves and the project leaders was essential to the success. As the research team collecting these field samples were wildland firefighters who volunteered to be part of the research team and train and collect a lot of this field data. And so in the boxes on the right, you can see what smoke constituents were measured, many of which are known, probable, or possible carcinogens. And so these studies considered an array of explanatory factors because, as Kelly really demonstrated, the contributing factors are highly variable. Some of them are listed here, and in this first bullet point. And one example finding from that most recent field study was that firefighter self-assessment of smoke was associated with measured concentrations of particulate matter. And so this really indicates that firefighters are pretty good at qualitatively assessing their own exposure to smoke. And this can be used to adjust tactics when firefighters are maybe experiencing high cumulative exposures to smoke, and be a really neat tool that they can use on the ground, especially when other monitoring is not available. The second thing that came out of this study was trying to look at some particular job tasks with high exposures that were identified. And both Kelly and Dr. Navarro talked about these as well. And so fire managers, this can enable them to start to target specific tasks such as mop up or firing or holding operations. Kat gave a great example during her Q&A of how they can kind of begin to target and adjust some of these tasks that may have higher exposures. Overall, these studies found that smoke exposures have not significantly reduced over time, but in comparison to some of these established occupational limits, only a small percentages of the shifts exceed different occupational limits. But it was really determined that based on some of the shift lengths and like how long term these exposures are, that some of looking at kind of the average over a shift and comparing to those occupational limits isn't as useful as comparing to some of the more short-term limits that might happen during these periods of higher exposure where they're in certain job tasks or there's certain fire behavior or they're in a certain geographic area. So really looking at these short-term limits along with trying to create some occupational exposure limits that are more specific to wildland fire. And that can give us a better idea of what these limits should be for this environment and how often they're being reached or exceeded. And so based on some of these key findings, management tactics to reduce overall smoke exposure were suggested out of these studies. So mostly focused on administrative controls as well as PPE in the form of hopefully designing a wildland specific respirator in the future. But when looking at the second bullet point here, one example that seems to be a pretty adopted practice by many incident management teams is thinking about strategically locating your camps and your sleeping areas for your personnel on fire, but also your personnel that are working out of those base camps 24/7 for long periods of time. And so if possible, locating those in areas with clean air so that all fire personnel have time to recover when they're off shift or they're coming back and sleeping in that camp or they're working out of that camp at all times. And so, really supporting incident management teams, taking this into account when they can and can't do this and what that means for exposures on that specific incident. And so some tactics are a lot easier to implement on prescribed fire versus wildfire. But as mentioned, a lot of these just kind of come back to targeting the tasks and situations where we know exposure is high and we can do something about them in real time. And so results from these studies also suggested some larger level changes such as medical surveillance and exposure monitoring, as well as just expanding the framework to also managing other risk factors. I know that many speakers have talked about this today, and it's been a really great theme of the conference of just that we have to look at the total worker health and their exposures both on the job and off the job. We can't just look at some of these little pieces in a vacuum because they're all concurrently happening. As well as, developing training for wildland firefighters of all levels. So when that first year firefighter comes in, they are really given the information on what some of the risks are and what some of the hazards are going to be when it comes to, like Kat was saying, some of these unseen hazards that are more long-term and harder to conceptualize on that short term or when you're on the job right now. And so another suggestion was, doing a lot more monitoring of smoke. And so the Interagency Wildfire Air Quality Response Program is one area of monitoring that is interagency, but it's led by the Forest Service. It is a separate program, was not created from the recommendations from these studies, but exists as a really great, comprehensive and growing monitoring program that was created to directly assess, communicate, and address risks posed by wildfire smoke to the public, as well as to fire personnel. And so one really important component of the program is made up of these air resource advisors who are dispatched to fire incidents They model, monitor, and communicate smoke impacts to the incident management teams, as well as air quality regulators and the public. They can help incident management team make decisions that can help reduce the exposures for the personnel on their fire. And so on the right, you can just see one small piece, one little snippet of a recent smoke forecast outlook. And these are issued in areas where smoke from wildfires are of concern and air resource advisors are deployed. And so this is just one little snippet of one piece of a smoke outlook from Wednesday from an air resource advisor down in a fire in New Mexico. And so there's a lot that we can apply from existing research and continue to figure out how can we build these best practices into all these areas of wildland fire. But with this always really comes a lot of challenges. Like, how do we target exposures of most importance in a highly variable environment? How do you design appropriate PPE for this type of work? How do you implement successful training that is going to be adopted? And that really comes back to kind of understanding the culture, thinking about how we can make these small changes and hopefully over time change the culture. And then where do items like carcinogen exposure fit in when these exposures happen in the context of all occupational exposures and hazards, as well as individual risk factors that firefighters have? So how do we manage these multiple hazards over time? And so then, you know, along with the challenges and in relation to those, the challenges of applying existing research, we also have a lot of research gaps that, unless filled, they make these targeted interventions really tough to develop and know, you know, where we want to target. And so longitudinal and epidemiological research to begin to understand the cancer burden and some of the other long-term health effects is really, really important. And then a lot of these gaps are related to multiple of the areas that Kelly was talking about that are common part of the job, such as what is the risk from exposure routes other than inhalation? And then one really great question is just how could small practice changes make a big difference in this environment? And so with that, the Forest Service is really looking to identify best practices from established research and putting a focus on engaging in the continued and new collaborations. What can we learn from these best practices that are already in structure fire, in the structure fire world? And then, you know, one area of that, like Kelly was talking about, thinking about our dirty PPE and decon procedures. But overall, the hope is to partner and collaborate with experts and advocates and firefighters to really just better understand these array of hazards and their health impacts, and then how these hazards interact with one another, and to promote this awareness among and work with firefighters directly to help develop the most effective ways to protect their health. And so with that, I really just hope that some of what we talked about today can invoke thought and conversation around how we can look at the wildland fire environment and implement best practices. We want to say thank you to this great groups of folks and so many of our collaborators and many people that we've probably missed. I want to thank everyone for allowing us to talk today and attending this session. We really, really appreciate it. And I think with that, I'll hand it over back to Dr. Juan Martinez.
Kelly and Molly, thank you so much for a wonderful presentation. I was really excited to hear both the scientific component as well as just the practical component of being an experience with wildland firefighters. At this time, I'd like to open up the floor to the audience here in the hotel, as well as those who are online for any questions. Please use the app to transmit questions over to us here at the podium. One of the questions that I wanted to ask you both is, I realize the science on sort of exposure assessment within wildland firefighters is evolving, and we're learning more and more about both short-term and long-term acute exposures. But are there any practical interventions that you can see that could be done in terms of mitigating some of those exposures on scene? Because, for example, in structural firefighting, we think a lot about decon procedures during the rehabilitation phase, but that's not a reality, I imagine, you know, when you're on a 2-week roster out in the middle of the forest and may not even go to base camp, as we learned today. So is there something, you know, I can't imagine you're carrying so many things. Is there something practical that you recommend to wildland firefighters that may be watching in terms of sort of decontamination procedures or things they could do to protect themselves during their tour, whether they're out there in the field?
That's a great question. And I'll start it off and then turn it over to Molly. I think recognition is one of the first things, and understanding the importance of. We talked about sleep, and that's one thing that until you really are deliberate about understanding the importance of sleep in our recovery and overall health, I think it's important to overlook. And so if we really start advocating for what these toxins on our skin, the way we're inhaling, ingesting, etc., are affecting or could affect our overall health, I think that's truly a beginning and changing that culture. Now, the logistics of providing for those opportunities, I believe we can overcome them once we understand them better. Molly?
That was a really, really great question, really great response, Kelly. I think right now, just from what we know, a lot of it too comes down to those administrative controls that we talked about. I mean, I just think about the story that Kat was telling about what makes sense and adjusting tactics to really, when you can, to really focus on some of these exposures. And so just her story about being in smoke that was so thick that, they couldn't see and they weren't able to, as effectively complete their task while, and it just kind of made sense to adjust their tactics. And that not only were they able to still complete their assignment, but they were also able to reduce their exposures in doing that. And so I think, like Kelly said, that first step is just being aware of what are some certain conditions or job tasks or certain things that are going to increase the exposure, and how might we just adjust the tactics, maybe of how long a crew is in there or how much they really need to mop up, and just when possible, just adjusting some of the ways that they fight fire, or even on prescribed burns, a little bit more leeway to kind of use different tactics to reduce those exposures, and just kind of continue to practice that to cut down on some of the overall cumulative exposures. But I really think that first part is getting that training and that awareness out to all firefighters, so they can really kind of have that information and just really know, okay, what are these tasks that we can target, and they can really think about the best ways that they can do that while still getting their job done.
Thank you. Do you think practical interventions like maybe wiping while they're there, if they choose not to go back to base camp, would be effective as well? So I realize probably carrying a bottle of wipes is another extra thing, but do you think it's practical enough, or it's cumbersome with the workflow?
I think that's very practical. And, it would really hope that it would be effective. I think that's one piece that, and I know there are some very recent studies looking at the effectiveness of wipes on reducing PAH exposures in wildland firefighters. I'm not sure exactly what the results of that study were, but also being able to, like you're saying, it's a pretty simple practical application, and then getting some researchers out there to see, what is the effectiveness of that intervention, and then how might they tweak it.
So a question that has come up from the scientific community is often, and I realize wildland firefighters is no longer a season, but almost year round these days or these years. For wildland firefighters that have second jobs, how should we consider or factor in exposures from something else that they do in addition to what they experience as wildland and wildland urban interface firefighters?
Molly, do you want to take that one?
Wow. I think that's been a really great theme of this conference, and a lot of folks talking about that, of thinking about some of these lifestyle factors, especially when it comes to, fatigue, fitness, nutrition, and some of these more preventative things that firefighters can work on. And so I think that gets, I don't really have a good answer to that question. There's a lot of people I might, want to ask otherwise about that, but because there's just such a variability of, firefighters' length of season, but the ones that do have a little bit of off season in the winter, the variability of, what their jobs are, what they do, could be really, really hard to capture. And so I feel like that would kind of come in and having more of a comprehensive, like, medical surveillance and monitoring program developed over time.
I think the important thing to note with that question is, and was noted by the speakers before us, is once we're informed and once we're educated about what a lack of fitness does for our overall health and well-being, sleep deprivation, cumulative fatigue, all of the things that we talked about, those hopefully can apply to just us as humans and our everyday behaviors and actions in life. And then, and that's how we show up for our profession, whether it's working, part-time as a wildland firefighter and then, in another position or not. But what can we do to become more resilient from both our physical readiness and our mental fitness as humans first and foremost?
Yeah, that's an excellent point. I think one of the things we've learned, one of the things that we've learned through this conference is the importance of education and awareness. Sometimes just knowing, that you have to self-monitor and be aware of what you come across is important. And then maybe as scientists, we can figure out the tools to be able to empower some of those wildland firefighters to use them to self-monitor. Along that same line, earlier you mentioned that drip torches can potentially also be sort of an exposure for wildland firefighters as well. So it's interesting to think about how the tools that you use to help you do the job can also potentially be a source of a hazardous exposure. Can you talk a little bit, for those that are not wildland firefighters, the scientists in the room, that how does, from your perspective, sort of that impact, whether through ingestion, inhalation, or sort of the health of the wildland firefighter?
Right. You want me to start with that, Mal?
Yeah.
Okay. Well, it's again recognizing, and boy, with age hopefully comes wisdom, or at least awareness and lessons learned. And so, I know as a young firefighter in the late 80s and early 90s, certainly I didn't think much about it, but when I still have the opportunity to get out on the line, I'm hyper aware of what I'm ingesting, and so the drip torch is one of the ignition items that we use, and it's a mixture of fuel in it, and when you light it initially, the smoke coming off of it can be pretty black, and as you're lighting fuel, again, a lot of times you're bending over and walking as you're doing that. And if you're walking, then there's a lot of times exertion, and so heavier breathing. And there is a substantial, okay, I'm not a scientist, there's an amount of smoke that comes off of that again is in close proximity. So I think there are some factors that we can be aware of, both in the utilization of those tools, but I also think it would be really helpful for us to better understand what truly the exposures are, because we certainly don't want to propagate a misunderstanding of those effects too. We're really good in the fire community at spreading information, and so we want good information. Perhaps, there are just a few things, modifications, simple changes we could make to the deliberate use of those items that would, basically remove some of the potential hazards inflicted and ultimately risk.
Well, thank you both very. Oh, I'm sorry, Molly. Go ahead.
Oh, no, I think Kelly answered it really, really well.
She took your thunder.
No, it was awesome.
Well, I want to thank you both very much, because we're just at time for this session, but it's really wonderful to have both the to hear the experience of the wildland firefighter, as a lived experience. So thank you both very much. Any final questions from our members in the audience? All right, so please join me very much in thanking Molly West and Kelly Kane for their presentation today. Okay, so we're time for our last and final break for the day. So we will resume again at 4 o'clock, where we will meet back here in this main room to go over a recap of the session, as well as our closing panel. So please join us right back in here, Palm C and D, at 4 o'clock, and we will resume right after that break.